Okay, we're going to look at mortgage renewals now. So after a number of years, usually 5 years or so, mortgages are renewed with a new interest rate. The present value equation is used to find the new value of the mortgage. So after 5 years, we're going to use the present value formula to figure out how much is still owing to the bank. A new interest rate with the formula above, with that initial formula way up there that we had, and new compounding period is used to find the new monthly payments. Now I've outlined a bunch of steps. There's 8 steps in order to do this. Okay, so first you find the interest rate using the interest rate formula for mortgages. Then you find n by multiplying years by 12. We're going to use the present value formula to find the regular payment. This is all the old one. Then find the new amortization period. So initial amortization period minus the term. I'll show you in a second. We're going to find the new one. Find n by multiplying the years by 12. So if initially it was 25 years and you subtract 5, there's only 20 years left. So then 20 times 12 is the new n. Use the PV formula to calculate the new PV using the new n. Okay, and the regular payment and old interest rate. So using the old regular payment and the old interest rate, we're going to find the present value using this new n. Now we're going to calculate the new interest rate using the formula, and then we're going to calculate r. Okay, with new I, N, and PV. It's quite complicated. There's 8 steps. I'm going to do one question, and then hopefully you guys can do 2 more. So I'm going to do one question, 8 steps. I'm going to follow these steps. Okay, step 1. So I'll go step 1. So step 1 is find the interest rate. So we're going to use I equals 1 plus S. Find the initial S over 2 to the power of 1, 6 minus 1. So we got a mortgage of $420,000 at 2.6 semi-annually is amortized 25 years. After the original 5-year term, the mortgage is renewed for 2.2% compounded monthly. Calculate the new monthly payment. So first, we're going old. Right near all this stuff is old. Okay, so we're going to figure out the old payment. We have to start this way. So we got 1 plus S over 2. So S is, let's use a decimal, 0.026 over 2 to the 1 over 6 minus 1. And we're going to use our calculator. So go over here. I'm going to use this calculator this time. So I'm going to put a bracket there. Bracket 1 plus 0.026 divided by 2, close the bracket, to the exponent, bracket 1 divided by 6 equals minus 1. And we got 0.002155. Okay, over here now. Okay, that's step 1. Step 2, find n by multiplying years by 12. So n is 25 currently times 12. So we're going to make 300 payments, I believe. 25 times 12. 25 times 12. 300 payments. Right now we're going to make 300 payments. Okay, so calculate the new monthly payment. Or calculate the monthly payment. So step 3, use PV formula to find, this is all old still. So we're going to use the PV formula to find our payment. So our current payment, R 1 minus 1 plus I. This is all old, so we're going to find everything for the old one first. And our PV is 420,000 equals R. We need to find R, so 1 minus 1 plus 0.002155 to the negative 300 all over 0.002155. Now we're going to use our calculator to calculate this. Clear all this. So bracket 1 minus bracket 1 plus 0.002155 to the exponent negative 300 divided by 0.002155. And I usually don't use this calculator, so I'm just going to switch over to the one I'm used to, the one I use all the time to make sure I get the right answer here. So we'll do this one instead. 1 minus bracket 1 plus 0.002155, the exponent minus 300. Close the bracket. I probably forgot to close bracket there. 0.002155. 220.77. 220.77. So 420000 equals R 220.77. Now we divide by 220. So our payment, so our initial payment here is 420123 divided by 220.77. So we're going to pay $1,902.43 every month. So that's all old. Everything there is old. Now we're going to draw a line. So that's our payment. Okay, that's our old payment here. Okay, 1902.43. N was 300. That's all old. And I. Now we're going to go with the new. But before we do that, first the next thing we're going to do is find what's the value after what's the value after 5 years, what's the value? So we're going to first go N. So after 5 years have gone by, so 20 years are left. So 25 minus 5, so 20 years are left. If you don't know what I'm talking about, 25 minus 5 is N. So our new N is 20. Now we're going to use the old I here. We're going to calculate our present value, our value of our money using the old I, using the 20 this time. 20 times 12. So now we got 240. So we're going to use the 240 in the formula here. 1 minus 1 plus I to the negative n. And R goes in the front. All over I. Now we're going to put the R. We're going to put 1902.43. 1 minus 1 plus 0. We're going to use the old interest rate, and we're going to just figure out how much money we still owe the bank. So this is all we're doing. We're figuring out how much money we owe the bank. We're going to find the present value after 20 years of the money. 0.002155. Okay, so all I'm doing, I just put in the initial interest rate, and then instead of putting 300, I'm going to find how much it's worth if it's only for 20 years. So 5 years have passed. So I'm going to find out how much it's worth here using that payment. So we're going to figure out how much 20 years of that is worth. So we're going to go to our calculator here. We're going to put all that into our calculator. So 1902.43 times bracket 1 minus bracket 1 plus 0.002155 to the power of negative 240. Close the bracket, divided by 0.002155. So right now we still have to pay 356,191.93. That's how much we still owe the bank. You have 20 years to go, so that's how many more payments we have. So that's how much we still owe the bank. We've already paid some of it off, but we still owe the bank this amount of money. So our present value, our present value, sorry, not RV, I'm thinking of traveling somewhere, but our present value is that. That's how much we owe the bank. Okay. I, so we got to calculate the new I. So you got to go all the way back to the question. Okay, so now we're going to compound it for 2.2% monthly. So instead of 2.6, we're going to go 2.2% monthly. So we're going to find the new I. We're going to use this formula, 1 plus S over 2 to the 1/6 we're going to replace 1 plus 0.022 all over 2 to the 1/6. So we're going to replace that there. So 1, 2. Now we're going to use our calculator here and minus 1 at the end. I forgot the minus 1 at the end. We're going to use our calculator and figure out what that is. So bracket 1 plus 0.022 divided by 2, close the bracket, to the exponent, bracket 1 divided by 6, and then we're going to subtract 1. And so we get 0.001825. That's our new interest rate. N is now 240. It's only 20 years. That's I. And our PV, we figured that out, 356,191.93. So now we're going to use our formula. PV equals R, 1 minus, so 0.93, if you didn't get it, it's the same as up here. It's the same as that one up there, the PV. 1 minus 1 plus I to the negative N, all over I. Our PV is 356,191, $356,093. R, over here we get 1 minus 1 plus 0.001825 to the negative 240, not 240, all over 0.001825. So 356,191.93. So 356, okay, equals R, and we're going to get an answer here. Oh, let's bring that up. Sorry, I wrote it all out. So we put all the information in the formula, and then it's here now. So just let me remove this sheet. Sorry, I didn't show that before. And we're going to put that in the formula here. That's 240. That's negative 240 up there. I'm going to throw that in the calculator. Clear. Bracket 1 minus bracket 1 plus 0.001825. Close the bracket, to the exponent, negative 240. Close the bracket, divided by 0.001825. And I get 194.2. So again, that was negative 240. I plugged it in here. I divide by 194.2. Divide by 194.2, and I get R equaling to 356,191.93 divided by 194.2. So my new payment is $1,834.15, less than the old payment. And then you just put therefore the new payment is $1,834.15. That's quite a difficult question.